Hey everyone, welcome to my channel. Now, welcome to Dungeon 2 or 3. One of those. 2 or 3. I lost count. But basically what we're going to focus on is this conquering of SAT. Now, for this particular SAT prep video, we're going to be focusing on the idea of quadratics, parabolas, so on and so forth. Now, each and every one of these problems that we're going to see today is designed to test you on specific topic, subtopic, or at least recollection of definitions. So hopefully with this video, you can actually look at a problem. If you can solve it right away, know exactly what to do, then in terms of that topic, you're a little more prepared than if you're completely stumped and have no clue. Utilize this video for that kind of self-test just to further prepare yourself for the SAT. Now, here's the thing. For our first problem, what is the coordinate of vertex for this equation right here? Y equals 2x squared plus 8x minus 5. Now, some of us might have experienced what we have is called the vertex formula, right? Some of us might not have. But interestingly enough, that vertex formula is a subsection or subpart of basically the quadratic equation. Remember, the quadratic equation is finding 2 points in the zero. Well, guess what? Any parabolas, no matter what it is, if you find 2 of those points, and usually with the quadratic equation, you're finding where it intersects the x-axis, halfway is where the vertex is located, right? Now, the quadratic equation actually gives you that. So, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully you guys have this memorized, or at least, be able to come up with this. There's a song as well. Feel free to look it up and sing it during SAT in your head, of course. Right? So we have this part right here. The plus or minus is what actually gives us this idea of 2 different areas. It's not the exact point, but it's just that 2 different symmetry. So this is our vertex, at least for the x-coordinate. So the formula for the x-coordinate in terms of the vertex is going to be x equals negative b over 2a. Well, standard form, this is your a, this is your b, and this is your c. C, not that important, but a and b. Alright, so that means our x-coordinate in this case is going to be x equals negative b, which is going to be negative 8 over 2 times 2. So basically, negative 8 over 4 or negative 2. Okay, we're not done though. This right here is only, once again, the x-coordinate. If we want the entire coordinate of the vertex, we need the x and y. Well, once we have this, make sure that we remember to plug it into the equation and solve for y. So in this case, we're going to have 2 times basically negative 2 squared, right? Plus 8 times negative 2 minus 5. Okay, and then after that we have basically 2 times 4 plus, well, negative 16, let's just write it this way, minus 5, and that means 8 minus 16 minus 5. What is that? That is negative 13, I believe. So our actual coordinate for the vertex, well, vertex is right here, let's just put it right here, negative 2 comma negative 13. Just like that, we found the coordinate for the vertex. Alright, so our next problem right here is still related to the vertex, even though it doesn't seem like it. It's asking about something slightly different. What is the equation for the axis of symmetry relating to this particular equation, right? Y equals 2x squared plus 4x minus 6. Now, luckily for us, we understand that with the idea of parabola, the vertex is usually where it's sort of the halfway point, right? And the fact that parabolas are basically very symmetric. There is, after you pass that halfway point, such that if you fold it, it should basically match alongside, right? Now, that is what we call the axis of symmetry. This line right here, where theoretically, if you fold it across this line, right, they fold and match exactly. That's what we're looking for in relation to this particular problem. Well, it's related to the vertex, right? If we find the vertex, then at least we can find that particular line. Well, the vertex formula, x equals negative b over 2a. Okay, cool. We have our A and our B. Well, if that's the case, we have x equals negative 4 over 2 times 2, which is going to be negative 4 over 4, simplified to negative 1. Okay, that gives us our x-coordinate. Sort of, right? The x-coordinate, if we plug it in, we get the y-coordinate, then we figure out the vertex. But actually, we really don't need the vertex at this point, we need this line. And now, this is the mini quiz on part of a quiz, right? So, how do we get the equation of this straight line? Well, since it is just a straight line across that x-coordinate, right? And it could be anything on the y doesn't matter. So the actual idea that x equals negative 1 is the equation for this line of symmetry. So there is your answer right there. So here we have our next problem, our level 3. What is the solution for 0 equals x squared plus x minus 6? Now, you'll see it written like this. You'll see it as an actual equation. They'll have like different wording such as find the 0. But overall, they're trying to figure out two numbers that would make a statement like this true. Now, there's a lot of different ways to approach it. Me personally, I would always try to see if I can factor it out. Remember, once you can factor it, right, you basically have two numbers that multiply together to become 0. So all you have to do is figure out what would make one of the numbers 0 and what would make the other of the number 0. Now, in an SAT test, there's numerous possible scenarios, but usually it'll be one that you can factor fairly easily. If not, then of course you use your next resort, which is the quadratic formula. But if you can factor it, always go with factoring, because usually after a certain amount of experience, that's a lot quicker and that's the one you should be aiming for. Well, 0 equals x squared plus x minus 6. Two numbers that add together to become this invisible 1 right here that we want and multiply together to become negative 6. Well, in that case, since it's a positive, we're going to have x plus 3, which would ensure that it ends up being positive when it multiplies and add with the idea of x minus 2. Okay, so there it is. Now we have to figure out when would this be 0 and when would this be 0, because these two are just plain multiplication. Well, x equals negative 3 would make this side 0. X equals 2 will make this side 0. So the answer or the solution for this is going to be x equals negative 3 or 2, right? So you have this possible situation. Now, if it shows up as like a multiple choice, it might only allow you one of these two options. So just be careful of that. They'll probably give you like all the other options that doesn't fit, and then one of these will show up. So the other one might not be, and you might think you have done it wrong. Not really. Just be very careful and double check your answers. Alright, level 4, you guys. Is the solution to x squared plus 2x plus 3 equals 0 real or imaginary? Now, it's really testing your understanding of the definition of imaginary and what to do in that case. And how would you determine if it's imaginary or not? Remember, when we're talking about imaginary number or complex numbers, basically, we're talking about situations where you're taking the square root of a negative number. So, let's look at this. How would we know? Well, square root should ring a bell, right? If we're looking for the solution of this, either you factor it out if you can, or you basically use the quadratic equation. Well, let's just use the quadratic formula, right? So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, the key to this is that it's just asking a yes or no question. Is the solution real or imaginary? Well, that means we don't really have to figure out the solution itself, just to see any small traits that will let us know if it's imaginary or not, right? Well, here we have negative b, which we know this, once again, a is right here, which is the invisible 1. And then we have our b, and then we have our c. The most important thing to determine if it's real or imaginary is this guy right here. Guess what? If you're taking the square root of a negative number, it's imaginary. If it's a positive number, then it's real. So let's just look inside here. B squared is going to be 2 squared minus 4 times a, right? It's going to be 1. And C is 3. So we have 4 minus, and this one is 12. So you're taking the square root of 4 minus 12. Well, we know 4 minus 12 is negative 8, square root of negative 8. So without even continuing, we know that it's going to be imaginary, because guess what? Square root of a negative number, negative 8, is going to produce an imaginary result. All right, so let's try something a little different. There's going to be another problem, the grandmaster, the final boss of this particular level. Now, before I show you guys this, please like, comment, and subscribe, because guess what? It will guarantee you that you will do better on your study for SAT. Does that guarantee you a higher score? Not necessarily, but at least that you've got this far. You've seen certain topics you might need to review and certain topics that you feel like you are more comfortable with. So let's move on to the final boss. Alright, so man, writing this is like, you've ever watched Simpsons where Bart is writing on the chalkboard for a long time? That's what it felt like. Now this is one doozy of a problem. It has a lot of different vocabulary that you have to really sit and understand to see what this problem is asking. So we're working with a parabola that has a vertical axis. Now the key to that particular statement is the idea that it's going to be a parabola that goes up and down, not left or right. Right? Because you know you always have that possibility that it's opening up to the left and opening up to the right. That's not the case for this one, right? It has a vertex at the origin. So luckily for us, if the origin is right here, then we know it's going to be on the coordinate axis looking like that or flipped over. Now, it intersects y equals 6 at 2 points, right? That's important, and it passes through the point 77. That's good as well. What we want is, what is the length of the segment joining the 2 points? So if we're looking at y equals 6, so let's just say 1, 2, 3, 4, 5, 6, and this is just a rough sketch, and you have a line that goes through it like that. Okay, so that means it intersects it at 2 points. We are trying to find the length of this guy right here, right? So that's what we're trying to do. All right, how can we do that? Oof, that's going to be tough. All right, well, first and foremost, it would always be good for us to try to figure out the equation for this parabola. We know that the parabola is going to be something x squared. Y equals maybe something x squared. The reason for that, because in the general form, right, we're looking at the different possible center. Well, since the center is going to be origin, right, it's going to be 0, 0. So there's no h, there's no k. We just have a times x squared. But we need to figure out what a is. A is just a substitute variable for some number that we don't know. But we know that it passes through the point 77. So if we plug in 77, we can figure out what a is. So that would give us what? 7 equals 7 squared is 49a. That's what we're trying to find, right? The a. So we're going to divide by 49 on both sides. So that gives us that a equals 1 over 7. Cool. So our equation is y equals a, or not a anymore. We figured out a, right? 1 over 7 x squared. Okay, so we have that so far. Now, we're looking at when it intersects the line y equals 6. So we plug in 6 here. What do we get? We get 6 equals 1 over 7 x squared. And then we multiply 7, which is 42. Then you square root it. So x equals square root of 42. Now, here's the kicker. You're almost done. The idea is that, well, one of them, this is probably the positive version, right? That's square root of 42. Since we're trying to find the length of this segment, and we know it opens like this and is symmetrical on the origin, if we want to find that, and here is square root of 42, that means here must be square root of 42. So the final answer, this length right here, right, is actually going to be 2 times the square root of 42, or just 2 square root of 42. And of course you can simplify it as much as you want, but basically this right here, this 2 times the square root of 42, is your final answer for the length of the segment joining these two problems. All right, so there you have it. 5 different problems. Each and every one of them focus on a different topic subset of parabolas and quadratics, right? You guys check them out. Hopefully you guys are more prepared afterwards. If not, you know which part you need to focus on, what you might be potentially stuck on. And it might be something like this. Then you just have to look through more problems that are of similar fashion, testing out your definition understanding, and so on and so forth, and get better at it. I know you can do it. Thank you for watching this video. I will see you in the next one.